In this video, you'll learn how to break apart a composite figure into more familiar figures and use given dimensions to find the volume. Recall that composite figures are made up of simpler figures. To find the volume of composite figures, first break apart the composite figure into more familiar figures, such as prisms, cylinders, cones, and pyramids. Then determine the volume of each familiar figure. Finally, add or subtract the volumes as appropriate. The volumes should be added if the figures are combined to make a larger composite figure. The volumes should be subtracted if one figure is removed from another to make the composite figure. Let's look at an example. A grain silo is in the shape of a cylinder with a cone on top, as shown below. What is the volume of the grain silo? The first step is to break apart the figure. You'll notice that this has already been done. The bottom figure is a cylinder and the top figure is a cone. Now we need to find the volume of each figure. Let's start with the cylinder. The volume of a cylinder is pi r squared h, where r is the radius of the base and h is the height. In our figure, we are given the diameter of the base as 20 feet. The radius is half the diameter, so the radius is 10 feet. This means that r is 10. The height of the cylinder is 30 feet, so h is 30. Substituting 10 for r and 30 for h into the formula for volume gives pi times 10 squared times 30. Now let's look at the cone. The volume of a cone is 1/3 pi r squared h, where r is the radius of the base and h is the height. For the cone, we'll need to find these dimensions as they are not given in the figure. First, let's find the radius. The cone and the cylinder below have the same circular base. Because the radius of the base of the cylinder was 10 feet, the cone also has a base with a radius of 10 feet, so r is 10. Now we need the height. We are given that the height of the entire silo is 35 feet, and the height of the cylindrical portion is 30 feet. This means that the height of the conical portion must be 5 feet, so h is 5. Substituting 10 for r and 5 for h into the formula for volume gives 1/3 times pi times 10 squared times 5. Because the cylinder and cone are combined to make the composite figure, the individual volumes must be added together to determine the volume of the grain silo. So the volume of the grain silo is pi times 10 squared times 30 plus 1/3 times pi times 10 squared times 5. Let's look at another example. A square pyramid is removed from a cube as shown below. What is the volume of the figure? The figure is given as a pyramid removed from a cube. We'll need to find the volume of both figures. Let's start with the cube. The volume of a cube is s cubed, where s is the side length. In the figure, we are given that the side length is 3 inches, so s is 3. Substituting 3 for s in the formula for the volume of a cube gives 3 cubed, or 27. So the volume of the cube is 27 cubic inches. Now let's find the volume of the square pyramid. The volume of a pyramid is 1/3 base times height, where b is the area of the base and h is the height. In this case, the base is a square, so the area of the base is s squared, where s is the side length of the square base. Because the base of the pyramid is the same as the base of the cube, it follows that s is 3. The height of the pyramid is given as 1 inch, so h is 1. Substituting 3 for s and 1 for h into the formula for the volume gives 1/3 times 3 squared times 1. Simplifying gives 3, so the volume of the pyramid is 3 cubic inches. Because the square pyramid is removed from the cube, its volume needs to be subtracted from the volume of the cube to determine the volume of the figure. Substituting the known volumes gives 27 minus 3, so the volume of the figure is 24 cubic inches. Now you know how to break apart a composite figure into the more familiar figures and use given dimensions to find the volume. Thanks for watching.